Assalamu alaikum wa rahmatullah. Welcome everyone to Introduction to Industrial Engineering. And here is today is the part 2 of manufacturing systems. We have talked in the previous session in manufacturing systems, the definition of manufacturing engineering and how it's focusing on the design of the process that producing a product. Also, we have talked about the product design and manufacturing engineering and how they interact with each other and what is the difference between them. Also, we talked about the computer-aided design and computer-aided manufacturing, and also some softwares examples for the computer-aided designs. We talked also about the robotics and different types and configuration for robotics, as well as we talked about the automation and the computer integrated manufacturing. Today, we will continue with the manufacturing engineering, and we are going to focus here today how the manufacturing engineering and process engineering, if you recall the definition of the manufacturing engineering is the one that focuses in particular for the steps in designing the process. We talked before about the functions that the manufacturing engineering do and the definition, which includes designing a process that produces a product at the end. Today, we will focus on designing this process, also known as the process engineering, which is the same under the manufacturing engineering, but the name comes here in separate or individually. Due to that fact, it could be also applied to any other fields than production. It can be to a service, for example. So the process engineering is under the manufacturing concept, and it can be applied for both the production or the service. The steps for designing a process is listed here as 6 steps. We talked before about the functions of the manufacturing engineering, which is similar somehow to the steps, but the steps is more of actions in sequence. So you start and you end with this steps. You start with defining product structure and specification, مواصفات وهيكلة المنتج, assessing manufacturability, and here you determine or evaluate whether it's difficult or how complex is your manufacturing going to be, or how simple. So you evaluate the level of complexity in this here. Determining the process capability of producing a part, and the capability here is different than the complexity. Producing the part and meeting the specifications, this has to be ongoing on your production. Variation is not acceptable if it's very high and exceeding your specification, even though you could manufacture it, but if it's not meeting the exact specification, then you have to work your process out. There is a separate sessions talking about the process capability and how you calculate the process capability for a process. In the quality control course, you find it over there if you are interested to learn more about the process capability. Step 4, which is evaluating the cost of each process. And when we talk about cost also, this is how it's related to engineering economy course, and you see how things are all connected to each other in the industrial engineering, and this is the unique about it. Everything is connected, and also it's connected to real life. Step 5, determining the sequence of operation, where it starts and end, and then at step 6, you document the process. Process engineering, usually it's a high-paid job, but at the same time, it's not just a routine job. Every day you have a different challenge. You work in shifts. Sometimes you work night and then days, because usually you are working with a plant or a division that never stop. It works 24/7. As it's highly paid job, but as there are some cons for that. If you are not willing to take or you are don't have the capability of taking stress and working under pressure and being working in different shifts, that maybe the job description is not maybe the right for you. It's not office work, definitely, and maybe due to the pandemic of COVID-19 that people, we see that working remotely from homes or other places that other than the actual office. This not applicable here. You have to be there in the production line or in the operation department, whatever is manufacturing or service. But the good also thing about it, you can predict that the place, if it's going to do some short or layover for employees, because usually places where is such environment of process engineering required, they don't just stop for the sudden. Shut down for factories, plants is not easy and is not cheap. So you expect if something like that will happen, you will have a head notice and you will have a time to settle your things. Examples like food industries that work 24/7, that they, not food industries, I mean restaurants. I'm talking about the food factory itself. Airline industry, if we are talking about even the service of the operations, اللي هو مركز العمليات والتحكم for the operation. This is one of the places that never stops. It works 24/7, even holidays. When we talk about also, for example, like the oil industry or petrochemical companies. So all these can be example for the process engineering job. We'll stop for fixing the connection. Okay, here we go again. And moving on the steps here for the process engineering. The process engineering, as we said, it contains 6 steps, starting with defining product structure and specifications. Product structures are often be in such similar graphical like that, hierarchical chart that shows all the sub-assemblies and components, raw materials that integrate with the product. So you start with the product, and then you start with sub-assembly, the major one, and then sub of those sub-assemblies, and they refer to the first sub, they call it SI or S1I, referring to the sequence. You have maybe 1 to 2 or more than major sub-assembly, and underneath each one of them you will have sub of the sub-assemblies, and they refer to that as a SS. Then the CK here, well, not Calvin Klein, but it's the component. So this component for those sub-assemblies, for example, iron, steel, rubber, and the other sub-categories. So the raw material is the CK, and then we have the RI, which can also be referred to R1 to any number of R's that needed, and that is the raw material. So the component, whether it's some devices or يعني خلينا نقول electronic chip or motherboards or hard disk, for example, the raw material that is used to manufacture those components, if it's need to. And if we take an example of maybe complex system, because it can be easily. So the product here, like car, then we have the electrical part, and then we have the mechanical part. The electrical part also has sub categories, and those contains of the PCM, or the computer for that car, and the screen. And here is the raw material, that is the glass of the screen that interface with the driver. And here in the mechanical side, we can talk about the steering wheel، اللي هو الجهاز او قياده التحكم اللي هو من الدركسون، واللي هو الالاينمنتس والاذرعه حقت التحكم. الكومبوننت it could be all these listed، اللي هو من عجله القياده لقاعده العجلات. الرو ماتيريال it could be the steel that used, or the rubber في اللي هو بعض الجوينتس البارتس. So this is how usually they do the defining the product structure and specification. So it can be all assembled in one chart, so that you can track the raw material and the component for that product. Moving with the second step, that for the process engineering or designing a process, is assessing manufacturability. And here we said what we do here is measuring the let's read it here. Manufacturing of an item is a measure of the relative ease or difficulty of producing an item with tolerance. Tolerance اللي هو المواصفات يعني المتاحة في التغير. Tolerance يعني acceptable. For example, you are producing let's say a bottle of water, and that is 330 millimeter size. So you have a tolerance, usually like a fraction of milliliter, that is acceptable. So it's a plus minus thing. And you, in the manufacturability assessment, you say how easy or difficult to produce it. So that what you are going to work on, and it's very related to the following step, which is the cost determination that comes after in the coming steps. Because here, when you say it's complex or easy, you will refer how much resources or money you need to spend to achieve that level of manufacturability. So the tighter tolerance، يعني الtolerance اللي هو المواصفات اللي يكون فيها plus or minus very tight, you don't have that much of tolerance in your specification, that usually acquire more expensive, and it will be more costly to your production. The third step is determining the capability, and as we said, the capability is examining the specification for each item and the capability of the various process. A list of candidate process can be developed. You can develop alternative of processes and evaluate which one will meet your specification. The capability of the material and the process, the ability of the process to produce within the tolerance, redesign the process if it's needed, and the availability, that's mean the operating time or the total time where is the process available to produce a product or process transactions. There is usually here analytical or deterministic calculation for calculating the process capability. As we said, the difference between the previous and this step, there you evaluate the ease and difficulty, the technology maybe you need to acquire to maintain the tolerance you are working on. You also review the tolerance. Here is you work on, after you establish the tolerance, how your process or how alternative process can achieve that tolerance, and you evaluate the process capability. There is calculation called process capability index. You can, as I said, watch that related recorded session and learn more about the process capability. For the cost estimation or evaluating the cost of the process, there are two different types of cost. We have to identify them from the beginning. The first one is the fixed cost. The second is the variable cost. What are the difference between them? Think about a plant, مصنع, okay? This plant, they pay for their land, whether it's rent or which they purchase this land. اللي هو سعر الأرض اللي هم فيها المصنع سواء كانت إيجار أو شراء. And think about the raw material. Raw material, المواد الخام that used to produce the products. Those are two examples, one for the fixed cost and one for the variable cost. How we identified that was fixed and this one is variable. A land cost is fixed. Why is fixed? Because it's not related to the number of the production. If you are producing 1,000 units per day or 100 units per day, it will not matter. At the end of the year, you will pay that exact rent, or you, if you purchase that land, so you pay it anyway. So any cost that is not associating with the number of production, we call it a fixed cost, okay? At the minimum wages of your labor, إيش يعني minimum wages؟ اللي هو الحد الأدنى للأجور. You have 50 employee or labor working. The minimum you will pay now, let's say 3,000 to 4,000 riyal. That's you will pay it anyway. We're not talking about the incentives or the regarding of how senior is that person, or this is a minimum you will pay it anyway, regardless of your production. Now, the variable cost is the opposite. Remember when we said the raw material, if we are going to increase our production rate, we will require more material. So the raw material considered to be a variable cost because it's associating with the number of production. This is as easy as that. So this is how you distinguish between the fixed cost and the variable cost. And also this one is discussed in details on chapter 13 in the engineering economy course under the break-even analysis. If I'm not mistaking the chapter name, but it's under the break-even analysis. You can watch it on the engineering economy course and you can learn more about the fixed cost, variable cost, and how you get the break-even point, where is the optimal production rate has to be. And why I'm pulling this here and saying that is the industrial engineering, as I said, is something that all the courses and all the knowledge you are learning, it's integrated. And that's why even this section or this area of study, what we covered, we didn't say it's manufacturing engineering because the manufacturing engineering as itself also is overlap with the mechanical engineering program. But the industrial engineering deals with systems, and those systems, if you think about them, they are integrated with the subsystems or sub areas. And as we are doing here in the manufacturing systems, we are dealing with the process engineering, which is different than the product design, and it's different than the mechanical engineering program, which also has a manufacturing. Here you deal with the overall picture. What you are doing here in designing the process and steps and calculating cost and also evaluating the process capability, that's not just a technical engineering work, and it requires many skills and many knowledge about different aspects in the field. So going back here, how we calculate the total cost? A total cost is the fixed cost plus the variable cost. But the variable cost, since it's a variable, متغير, how we calculate it? The variable cost is the cost per unit, the cost per unit, يعني سعر الحبة, times the number of units, times the number, how many units you are producing. We will take an example to explain how we calculate the total cost since it's important. Imagine, or example, you have this given information for process A, and then I have alternative maybe, or another process B and process C. I have the fixed cost for process A is $0, $2,000 for process B and $8,000 for process C. The cost per unit، سعر اليونت الواحدة $10 process A، $8 for process B, and $5 for process C. How we calculate the total cost for each alternative? We will take this example says calculate the total cost for each process. Sorry, this is typing mistake. For each process at a quantity 500 units. يعني find التكلفة الكلية at 500 وحدة. عندي إنتاجية 500 وحدة. Each process, how much is the total cost? As we said, the total cost is the fixed cost plus the variable cost. السعر الثابت والسعر المتغير. الثابت الفixed $0 here for process A plus 500. Why? لأنه إحنا we want to find it at 500 production rate. The 500 units times the variable cost 10, that will equal 5,000. For process B, the fixed cost is 2,000 and plus 500 times 8, which equal to 6,000. For process C, this has to be 8,000. It will be fixed and updated in the shared folder. So 8,000 here, not 2,000, and I can type it here so you don't get confused because that's from the table. It's 8,000. 500 times 5. That's equal to 10,500. Okay, so we see it here, it's fixed. So you can just ignore that 2,000. So it will be 8,000, the fixed cost, plus 500 times 5, which equal to 10,500. That's the total cost for each process at 500 units. So if you want to compare, let's say your production rate or your target rate for production is 500 units, let's say per day or per hour, depending on what you are manufacturing. And you would like to evaluate those alternatives for A, B, and C. Now, which one has a least total cost? Alternative A shows is the least one, then B, then C. If you change the production rate, you may have a different evaluation. So you can try it at 1,000 units, let's say, or 2,000 units, and see which one shows, are they going to show the same or different? You can assess it also and evaluate it. And this is how the cost evaluation comes. As I said, there is more details about this and how you find the point where it's equilibrium between them. That's all discussed in the engineering economy course. For the last two steps, which is determining the sequence of operation, when you do the sequence, where you start and where you end, and the sub-steps that needed to be done for the process, you have to consider the minimization of part handling, so you don't do movement. And why we don't do that? Because that will be a waste in your processing or your production time. Again, this is related to the lean concept, اللي هو أو lean management، الإدارة يسموها الرشيقة، اللي هي قليل الهدر فيها يكون من التايم والcost, and all this discussed in quality improvement methods course under the Lean Six Sigma, where you can also learn about the lean and what this mean. But here, what we try to do is minimizing part handling. If the part is routed, يعني إذا القطعة بتدور من مكان لمكان, so we try to minimize it and find the shortest path to do your process. The shortest path also can be done using tools like critical path. So you know which steps has to be before other steps, يعني prerequisites زي courses. When you take this course, Introduction to IE, you should have completed math and engineering design, let's say. So the shortest path, when you are in the first year, you have to think about those two courses first to complete them anyway. If you are going to reduce load, you don't remove those two courses. Otherwise, you will not be able to take this one, which will open another courses to you in the program. So this concept, they call it the critical path. You have to look for the shortest path when you design the process or the sequence of operation in your product or even in your service. The last step, which is process engineering, documenting the process. So you do create process chart. You have already now found the sequence. Now do it as a process chart or process map. So easily you can track your process, you can improve it, you can adjust it, and even you can train the new employee or laborers who are going to work on your plant. That was for the process engineering. Moving on in the manufacturing system with a new concept, or not a new concept, it's a related concept, but you are going to hear it maybe today in this course, but you will learn it also in depth and details in a separate course called facility planning. Facility planning, facility layout, plant planning, كلها all the same meaning, different terms. اللي هو تخطيط مرافق، تخطيط مصانع، إدارة مصانع، إدارة، طبعا نتكلم إدارة من ناحية إيش؟ We are talking about from the layout perspective. And why actually, before we go with the definition here, let's define it first, so at least you can get an idea before we talk why we are studying this. Facility layout is the arrangement of departments, work centers, and equipment with particular emphasis on movement of work, customers, or material through the system. So in facility layout or plant layout, هو from the beginning it was a plant layout، يعني تخطيط أو رسم اللي هو المصانع. Then it becomes to this word which is more general, and I like this word more, facility. لأنه facility it could be for production or for a service. You can also use facility layout in designing a hospital. And when we say the word design, as an engineer, the design starts from the building itself to the movement of working table or material handling system. Sometimes you have two plants or two facilities do the same job, the same operation. يعني think about two hospitals ولا two plants مصنعين, they do the same thing. Hospital, they do the same anyway because they do the same function. But المصانع maybe one for يعني خلينا نقول one for food, one for oil. Those are different. No, we're talking about two plants having the same operations. Okay, they may not have identical layouts. And why? Think about it. Why is that? Why they are not systemized and standardized? Because of the size of the plant. Maybe الأرض اللي هم بنوا عليها المصنع أو المستشفى أو الشركة اللي هم يعني البنك مثلا. A nature of the process. طبيعة البروسيس. We're not talking about operations. We're talking about the nature of the process. Maybe they have steps are different. The machines they are using are different. The technology they are using is different. Or due to the management caliber, for example. So all these could be implemented when you are going to work on facility layout. In the facility planning course, you will be taking this in details and in depth, and you are going to design and practice designing facility planning using يعني software applications. There are types of facility layouts. Product layout, which most helpful to repetitive process. We will talk about each one of them. Process layout used for irregular processing, excuse me. Fixed position layout used when product kept stationary, and the hybrid layout combination of any of those layouts. The advantage of the facility layout are many. يعني we can list many مميزات وأشياء ممكن تستفيد منها من facility layout. You cannot imagine. Maybe you think it's just a drawing. You do it for the building or the floor work. No, it helps you in removing bottleneck. Movement made by worker is minimized. يعني when you shorten the distance of movement, for example here, الرجال ده اللي بيشيل من هنا لهنا. Imagine if this station it was there and he needs to upload الماتيريال في الكونفير هذا اللي هو السير اللي هنا. فتخيل انه مثلا يعني افتراضا انه هو raw material will bring it from this side all the way to here. When you put everything in the right place, you minimize the movement of the worker. Waiting time of semi-finished product is minimized. What does it mean? This is not finished product. This is raw material. See, raw material is coming here. And if those are going to be processed into another line for the production, if the production line that connected to the next step is way long or it's far, then those they have to wait here or to upload them and put them in another step. So this going to be, because they have not finished yet, they are going to be processed. They have another steps to be implemented. So there will be the waiting time for those unfinished products is long, but when you do facility layout correct, you minimize even for the material waiting, increase the flexibility for changes in the product design, also for future modification. If you would like to do any changes here, it will be easier since you design it from the beginning, considering the facility layout concept. Also increase the space. يعني when we say increase معناها مو انك حتكبر المساحه. utilize، خلينا نقول الكلمه الادق utilize، الاستخدام الامثل للمساحه. improve work method، reduce production cycle time، بتقلل من الوقت اللي بيصير في عمليه الانتاج. to make also the work space safe. يعني this area it has to be, for example, designed in a certain material or ventilated in a certain way to be free from dust, or for example if you are doing food or some kind of that, or noise. So you have to design it in this manner, even for your employee safety, so they will be working in a place that designed considering their movement, so it will not be tight or it will not be يعني crowded. Increase productivity and product quality, also reducing the cost of production. When you utilize the space, you minimize the movement of the traveling for the material or for the labor you have. Also, the inspection will be even better when you implement it in such layout. So all these can be advantages of using facility layout. Is not something arbitrarily you do it and you just put this machine here and there. It has to be designed systematically using different concepts and different types of layout, and each one has many details, even more than what we are going to just explore today about the difference between them. But in the facility planning, you will learn more about this, and you can see how it impacts on the productivity and the work environment. Even your employee, they will feel that when they work in such place. Okay, so the type of facility layout, we have the first one, which is the product layout. And the product layout is standardized. They use it for standardizing or standardized processing operations to achieve smooth, fast, high volume flow, made possible by highly standard goods or service that allow highly standardized repetitive process. The work is divided into a series of standardized tasks. See the word standardizing process, standardized goods or service, standardized series of tasks. You see the word standardize, how it's coming. So that's why I'm highlighting them. So this is, you can refer these words, the standardized, to the product, so you always recall the definition easier by having just one word or acronym related to the type of layout. It works with large volumes handled. The system usually makes it economical to do the product layout. So you move from station to another station. يعني I give you an example so you can imagine what do you mean by product layout. Think about, I'm trying to give you an example that also we can use it in the coming one. Think about bakery, مخبز, مخبز عيش, but we are talking industry level. We're not talking those baking that comes in the supermarket, they do it. This is another layout, by the way. We will talk about it in the next. So I'm giving you this example so can you link things. في المخابز اللي هي الاوتوماتيك يسمون مخبز اوتوماتيكي للعيش مثلا الخبز. What they do, the flour or اللي هو الفلاور ايش يسموه الطحين ولا الدقيق والمكونات ingredients salt وsugar وwater, put them like in large quantity tanks or some containers. They empty them in a mixer في خلاط كده ويعجنهم هو automatically, and then cut it automatically, and then they move automatically in the heat oven, and then they go on the conveyor, and then the packing goes, collect maybe 5 or 7 breads, a loaf, and then put them in plastic bags. All that automated. Human, they are not interrupting these steps of process. هذا product layout. Standardized, mass production, highly standardized, يعني every step has a function, and a large volume works in this layout. For the advantage and disadvantage of the product layout are listed here. The product layout has many advantages. As we said, high rate of output, so you can have high volume, low unit cost, labor specialization, low material handling cost, high utilization of labor, استخدام يعني أمثل أو أتمتة لعملية الإكويبمنت، كل حاجة مقاسة بدقيقة أو يعني and specific time to move to another step، يعني من الخبز للعجن للخلطة واللي هو يسموه الميكسينج. كل واحدة منهم has equipment and labor to monitor and maintain the inspection, establish routing and scheduling, routine accounting, purchasing and inventory control. عندك التوقع لعملية المنتج كم وعملية الشراء والبيع والمخزون لأنه عارف ال production rate for this type of layout. The disadvantage, also there are disadvantages as all the other layouts. Any depend on your needs. You design the layout that suits your objective. Creates boring, repetitive jobs because they do the same thing over and over every day. Poorly skilled workers may not maintain equipment or quality of output. They have to be trained and skilled to operate with those equipments and machines. Otherwise, they can shut off the whole factory for mistakes happen. Fairly inflexible to change in volume. Highly inclined to shut down if mistakes happen or problems happen. Needs preventive maintenance لأنك you are working with big machines. Individual incentive plans are impractical. All these are a disadvantage, and as you see layouts, there are always plus and minus. As I said, you design it based on the needs of your factory or your even the service. As I said, it works for the service. So you have to think about it. What is my objective? What are the steps? You do the previous process engineering steps first. And when you come to the step number 5, when you do the sequence, then things will be clearer to you which layout you may think about for your work floor, okay? The second type, which is the process layout. The process layout handle various processing requirements. various هناك standardized. ها ركز معايا. هناك standardized، هنا various مختلف. هناك يعني موحدة أو فيها لها يعني ستاندرد ضوابط أو يعني توحيد في العمل. remember that example. خليكم معاي في موضوع البريد اللي كنا نتكلم المصانع الآلية. معليش خذوني كذا يعني اكزامبل بلدي شويه، محل حق التمييز ولا الفرن حق التمييز اللي تروح له كذا يعني this is the same. يعني خلينا نقول remember when we talk about facility layout, two things do the same operation بس different في layout و different في الكونسبت من ناحيه خلينا نقول البروسيس. هنا في المخبز هذا اليدوي الليبر او العامل هذا المعلم اللي قاعد يسوي he takes الفلاور او mix them ويشيل الدقيق من هنا ويحط المويه بيده ويعجن وبعد كذا يقطع هذا. وان if you have topping يبغاه يعني بالسمن ولا بالجبنه ولا بالبسكوت نجوعكم شويه ما هي مشكله. فيعني all this steps done separately, and this labor he's moving them يعني from place to place. He is conveying the material from step to step to different places. واحد مكان خلينا نقول اللي بيعجن وبيعمل الميكسينج فيه، بعدين مكان بيقطع فيه، بعدين بيكون في مكان قريب من الفرن تلقاه بيحط اللي هو يعني الريكوايرمنتس حقتك الجبنه. احيانا يصير اللي هو العجينه جاهزه جنبه بيفردها على طول، but this is already done. يعني انا talking about things he did it maybe behind يعني خلينا نقول الستيج اللي انت شايفه، لكن did it in this way. and then he puts that الخبز ولا التمييز في التنور هذا حق الخبز and he waits manually. وبعدين يجي الكاستمر يقول له ابغاه مقمر ابغاه ما اعرف ايه، فهي is waiting and observing يعني by his eye, and then he decided when he takes it out or he leave it a little and then he take it out and then he cut it, put it in the bag. All that done step by step manually, and he's conveying the material by himself to do those steps in different stations. So the process here, it's various in terms of the product operations. So the layout here of the place is different than when we talk about mass customization, mass production for the automated bread factory. فين هناك بيكون عملية العجن لها دقائق محددة ووزنية معينة لكميات كبيرة, and then to go to the next step عملية تقطيع العجين بتكون automated for also production rate and fixed, and الخبز بيدخل كله على نفس درجة الحرارة لنفس الوقت, is not about varying depend on the يعني requirement حقت الكاستمر, فبيكون هناك consistency, and the production rate because it's automated definitely is going to be higher. This is يعني basic examples. See, those can go on a big scales, and we will see in the next slide, so you can imagine how big they can go. But this is just to give you an example so you can imagine يعني the difference between them بحاجة كده يعني تفتح نفسكم شوية. Okay, the layout feature departments or other functional grouping in which similar kinds of activities are performed. يعني مكان الدقيق ومكان العجن بتلقاهم بيروحوا بياخذوه في مكان واحد where all the دقيق goes with the water والsalt والsugar, وبعدين بيعملوا العجين, بعدين ياخذون another station where the oven and all the breads goes to that oven. So they have department, or يعني طبعا احنا لما talk here it's more complex systems, department for each function. Okay, machine shops is very common examples اللي هو الورش المصنعية، الورش الخراطة، ورش الدهان، ورش اللحام. there is a station for خراطة اللي هو milling، وبعدين station for lathing، and there is station for painting, where is all the paint equipments there. So you take the material from a place to place to do the process step of that production. Different products may present quite different processing requirements and sequence of operation. You can do different products. يعني خلينا نتكلم here more يعني industrial level. When you do furniture, there is a painting section. That painting section can go tables, chairs, name it, يعني dresser. All these goes to the same section where they get painted, but they are different products and they have different steps or sequence in terms of the steps. Also, if you are doing really mass production, you may have a production line only specified for one of those items, and they have their own painting. But when we talk about something يعني more compatible to various different products and requirements, you may have station for each one of them, or department for each one of them, and you take those products there to do the same job. Let's take a picture and visual picture here. This is will talk a lot better than me and explain it. This is how the process layout. عندنا كده أجهزة الميلينج، بعدين أجهزة الليثينج، بعدين أجهزة الدريلينج. فالunits here, regardless of the product or the unit you are taking، زي ما قلنا كرسي، طاولة، ما أعرف إيه في البرودكشن لاين حقك، all they go needs to have done milling. فكلهم يعني ياخذوا القطعة هنا، they do the milling department. بعدين if it's need drilling then they will take it. Maybe some they need drilling, some others no, they need lathing. Maybe there is another department here, let's say painting, another department يعني do something else. So each the process layout هذا process layout various. Remember process layout is various، متغير. في كل department يعمل job مختلفة. In the product layout, the product process or sequence set first, then you design the sequence of the machine to do this job. فأنا محتاج milling، بعده محتاج عفوا turning here, then I need milling, then I need drilling. بعدين there is assembling, there is inspection, there is packaging. Okay, it has to be with this sequence. So you design it in this sequence. Your raw material goes here from the beginning until the packaging dispatch, moving all around, or يعني passing all these steps with the exact time, with a specific specification for time and rate. So here you can يعني think about it. You can even especially if it's automated, and remember the automation that we have talked about in the previous part, you can predict the production rate. You can use robots here to ease the process, because the conveying from step to step is fixed and it's follow a sequence that exact goes for all the products. Here sometimes products need this function and this function, but other product need this one, whereas others they don't need it. And the same, imagine if there are other functions. So the sequence also, sometimes maybe you start with this one here and then there. Product B, let's say you start with this here and this one, and then فهو يعتمد على ال department and process. Here it depends on the product. So the steps and الخطوات العمل تنعمل من البداية على احتياج المنتج. على احتياج المنتج. المنتج حق يحتاج الخطوة A B C D E. ال A هيحتاج فيها كذا كذا كذا، B هيحتاج فيها هذا الشيء وهذا التايم ونفس الشيء. كذا you do البرودكت layout concept. البروسيس لا، احتاج functions. functions معناها equipments، معناها يكون عندي department إذا ما كان عندي تصنيع كان service، قسم مشتريات، قسم مبيعات، قسم ما أعرف إيه. فيكون each division has its own function or process, and then based on the product that I'm working on or the transaction, if it's a service, I go to the divisions. So you can have various of products or transactions. Here you have more standardized production. This is يعني إن شاء الله hopefully يعني you get it clear now and distinguish between the process layout and the product layout. The last two layouts we have remained fixed position layout and the hybrid layout. Fixed position is very easy. It's different than all the other layouts that we have covered and talked about, or the product or the process. Here the product kept station يعني ثابت. Equipment move around it. When you are building like large ships, those like the cruise ship or the shipping هي الشip الميجا one, or airplane or يعني trains for example, or يعني sometimes you have large like shuttle اللي هو rocket، هذه الصواريخ اللي هي الأقمار حتى اللي بتطلع للفضاء. So you keep it stationary and the equipment move around it. So the equipment goes here and there. They build the layout around the product. يعني rarely أصلا you design a mass production. You are doing يعني few number of those ships and barely يعني to have mass production for them. So that's why you design your layout around the equipment. And يعني this is something that unique and depend on certain situations. The hybrid layouts, you combined any type of layouts that we have covered together, depend on your need. You can have product layout and process layout in the same يعني place where are you, or the factory or the company. A last thing, that why do we change or why do we make changes in the layout? Sometimes insufficient operation. العمليات غير مجدية، يعني you have to reorder it or redesign it in a way to be more efficient. تكون كفاءتها في حتى عالية في الأداء. high cost بتسبب له يعني cost عالي. waste time بيكون فيها عالي. البوتل نيك يعني ما بتقدر تنتج بالكمية المطلوبة، أو بيكون عندي تكدس في خط الإنتاج. So I have to change my layout from one phase to other or combine them two phase. They depend on your يعني situation. The introduction or development of new product or service. عندك منتج جديد, so you have to change your facility layout so you can adopt now this new product or service. Accidents or safety measures. صار يعني لا سمح الله يعني حوادث معينة أو مشاكل related to the safety, so you need to change your layout. Changes in the in environmental or legal requirements that require to have your facility designed in a specific يعني or follow certain procedure or specifications. من يعني authorization اللي هو الجهات المسؤولة أو الحكومات اللي مرتبطة مثلا وزارة الصناعة أو غيره. So you have to follow their requirements and adopt it to your layout. That was all for the يعني today's session. I hope you enjoyed. Today we have covered process engineering, how we design the process and how the steps to follow to do designing process for products. And as we said, whatever we learned from manufacturing, it can be adopted to the service industry or any other industries. Also, we learned today about plant layout or facility layouts, the advantages of them, the different type of them, and I hope you enjoy it and it was clear for you. Thank you for watching, and I will see you soon in